Hello everyone and welcome to lecture 2. In the last lecture we saw how to begin with Mathematica. We discussed some very simple algebraic manipulations. We learned about how to get numerical values, how to type special characters. We also learned how to expand the things we want. Let's say you have a plus b whole squared or a plus b to the power cube, this sort of things, very simple stuff. And today we will be talking about functions. That would be very important in our future discussions. So as you can see, I have written here this function f of x is given by 12x squared by 3, which is actually 4, but let's keep it that way, and 9x times sine squared x. So today we will learn how to declare functions in Mathematica, and then we will talk about how to evaluate their values. We will talk about adding and multiplying functions. We will then plot these functions and see what Mathematica has to offer about plotting and visual representations. And finally we will be talking about limits, that is how to evaluate limits of function when the x value approaches a very specific numerical value. And note that today we will be only dealing with functions of a single variable. So let's get started. So the first thing we need to do to declare a function, let's say I want to declare my function as f of x, and the first thing I do is I type f, then I give a third bracket, and then since I want my variable to be x, that is the argument of the function, first I'll type x and then I'll put an underscore, and then you need to get out of these third brackets, you put a colon, and then you put your equal sign. So as you can see, now this x is our argument of the function, and it has taken a green color, a very light green color, if you notice very carefully. And then we want to write the above function, that is this function. Okay, let's not keep it 3, let's keep it 7, let's say. So we want to write this thing. How do you write it? If you remember how to write fractions, you put control and the slash button, that is the fraction, the division button, then you type 12. You can either put a multiplication symbol or you can also put a space. Either way Mathematica will count it as a multiplication, but let's keep things simple and put a multiplication symbol over there. So we type x, then we power to the 2 and we type 7. We put our cursor over here, we type plus, we type 9 times x times sine, we put our argument x, and remember that in the previous lecture we talked about how to give powers to trigonometric functions, and just in case you get confused, you can always put a parenthesis, that is the first bracket, over here and write like this. So let's evaluate this. As you can see, Mathematica is not showing us any output, because after running this cell, this one, let me just show you guys, this one, Mathematica is now taking function f of x to be this expression. Now what we can do, let's say I want to evaluate this function at f of 0, that is when the value of x is equals to 0, what should this function return me? That's what I want to calculate. We can already see that the result should be 0, but let's type that. So to do that, again you will have to call the function. So to do that, you just put f, you put a third bracket, you just put 0. So and then you run the code, and as you can see, the result is 0. So what is happening here is that Mathematica knows that f is a function and x is the variable. That means not the variable, I'm sorry, x is the argument of the function. That is, f is a function of x. And after we let Mathematica know that, hey, we are declaring a function like this, then we are putting x equals to 0 in this argument section. And so what Mathematica does is that Mathematica takes x equals to 0, puts it into this expression, and gives us the following result. Okay, so far so good. But what if I want to see another number, let's say 1.5. As you can see, for 1.5 it's giving me 17.2896. Don't get confused by this line, because what happened over here is that Mathematica just took 0 as an input because I pressed on space. So this type of thing might happen, so you have to be careful about that. So let's just delete this and run it again. As you can see, now it is giving us the value for x equals to 1.5. So pretty easy, right? How to declare functions. Now let's declare another function. Let's say g of x, and g of x, let's say we want this to be a very simple function. Let's say 3x squared. We run it, and now let's say I want to add these two functions. So I type f of x plus g of x, and I run this code. As you can see, Mathematica has added these two functions, and it has given us the following expression. But let's say I want to evaluate multiplication of these functions. So what we do the same thing as before. We take these functions, we just put a multiplication symbol under it and run this code. As you can see, this is our expression. This is what we expect, right? But Mathematica hasn't actually multiplied 3x squared with 12x squared, which should have been 36 times x to the power 4 divided by 7. So let's see if we can do that by using a command called simplify. So this is a new command that we are seeing. So as you type simplify, and then you put this third bracket, and then what you want to do, you want to type this f of x times g of x, and let's see whether we have any luck with that. If we do that, Mathematica actually has simplified it for us. Okay, so now we want to calculate functions of functions. So let me write another section. We want to see functions of functions. That means we want to evaluate expressions like this that you often see in your high school calculus books, or you have seen in your Math 110 course or 120 courses. So let's see what Mathematica do about this f of g of x type of stuff. But since I took this f of x to be in a complicated manner, but still, let's see what Mathematica can do about it, right? So again, notice that this g of x is now equivalent to the argument of the function. So it's kind of equivalent to x right now. So to type this, we will again type f, would give third braces, and then we'll just put g of x. Let's see whether this gives us anything or not. if we do that, we have the result. So how this is working out? Well, let's do some analytic calculation or some mental calculation, a very small one. We declared g of x to be 3x squared, right? And if I put this 3x squared into x squared, that should give me 9 times x to the power 4, right? And we have a 12 in front, so that's 108, that is 108. So this expression is correct. Again, we have sin x whole squared over here, and we are putting what? Instead of x inside f of x, we are putting g of x instead of this x, right? So g of x was what? 3x squared. So this is 3x. So this is also correct, 3x squared. And here we had 9 and x. So instead of x, it is getting replaced by 3x squared. And you are having 9 times 3, that is 27, and x squared. So yeah, we can use Mathematica to compute functions of functions, and we can do further manipulations with it if we want to. So far we have seen only how to manipulate and get some values. So now I want to talk about how to plot these functions. That is, this is the most interesting part, that you can actually type really complicated functions in Mathematica and it will generate the graphs in a heartbeat. So that is a very nice feature of it. So now I want to talk about plotting functions. So let's say we want to plot f of x. How to do that? So the command to plot a function is just plot. The command is pl. As you can see, if you type pl, Mathematica will show you some suggestions, and you should go for plot when you are dealing with a single variable function. So I'll type plot, and if you give third braces, you will see that plot comes with 2 arguments. That is, the first one being, let me just explain to you guys that this f is the function, and if your function is a variable of x, that you have to specify which one is the variable inside your function, right? So let's say we are dealing with a function whose argument is x. So first you specify x, then you specify what is the minimum value of x, that is from which interval to what interval. That means that's the x minimum and this is the x maximum. Let me show you this example and it will be clear from this. So first we want to type f, but notice that you just don't type f, you have to put the argument of the function. So you have to type f of x like that, then you put a comma, you put curly braces, and then since our argument is x, first we identify the argument, and let's say I want to plot it for -10 to +20. So this is my minimum value, the x minimum, that is the minimum value of x, and this is the maximum value of x. So let's run this, and as you can see, this is how the graph looks like. Now what if instead of x let's say I declare another function, f of k, right? If you declare this like this, for example, sorry, not x, it's k plus 5k squared. I want to declare a function like this. I don't want to use x anymore. So I run this cell, then I use plot, and I will type f of k. Now I won't write x here because x is not my argument for the function capital F, right? So I have to identify my argument. So I write k. I want to plot it for -2 to 10, and if I run that, there you go. And in fact, Mathematica comes with another interesting feature that you can actually select these pictures, and if you right click on it, you can copy this graphic, you can save it, you can get some drawing tools, you can get coordinates, you can make it in standard size. Let's first take the standard size. Let's see what does that give us. And as you can see, nothing is happening. Why? Because it's already in the standard size, right? So let's see, you select it, right? And you can actually scale it up like this or scale it down to your convenience. Let's say I want to scale it up because that is convenient for me. And now what I want to do is I want to select some coordinates. Let's say I want to know that what is the coordinate of this point, right? So to do that, you need to right click first and use this get coordinate thing. And as you can see, as you move this cursor over this graph, you are seeing the x coordinate and the y coordinate respectively from left to right. That is the first one. That is when my cursor is over here, it is showing you that the first entry is the 3.70206 and the second one is 567.201. So the x value for this coordinate, that is where the cursor is it's 3.7 approximately. That's the x value of it, and the y value is around 567.2. So if you put carefully the cursor over these graphs, you can see these coordinates. And in fact, if you find some coordinates that are interesting to you, you can actually mark them, and that's just, you go over it and click on it. You can see it will give a dot over here, another dot, like this. So these are really nice features of it. Now instead of just plotting the graphs, we need some additional information. That is, we need to label them, and there are a lot of themes in Mathematica that you can use to your advantage. We will show them in the next example. So one of our favorite trigonometric function is the sine or the cosine function, right? This sinusoidal function that looks like waves. So I want to plot a sine function, let's say, and to plot it, I'll just go type plot. I'll type sine x, and I want to plot it for -10 to 10. This is something we have already seen, right? The basic plot command. Oh, sorry, I forgot to wrote down the argument. Yeah, now it will work. And as you can see, now what if I multiply this with, instead of sine x, you can always type 0.5 times x times sine x, right? And as you can see, this is another interesting graph. So now what you can do inside the plot command is that you can type another comma and you can do plot. Just type plot and you'll see a lot of suggestions. For example, you can see plot style, you can see plot range, you can see plot label, you can see plot points. So let's talk about this plot range first. As you can see, if you just click on the suggestion, you will see two suggestions, that is all, full and automatic. So this all if you choose plot range all, it will automatically drop out the points that are outliners. If we use full, it uses the full range, that is for x equals to -10 to +10, it will use the full range of the y-axis. Okay, and if you, let's do automatic. Now what you can do is you can put another attribute, that is plot theme. Usually I use plot theme scientific because most of the time that's more convenient to see. Let's see plot, and to get there, let's just use this drop down bar, and as you can see we have plot theme here. Just click on it, and as you can see, this is the web, this is the minimal, detailed, business, marketing, scientific, anything you want. In fact, it has more features like this: frame grid, color, bold, white, whatever you want. So let's go for scientific, and let's hit enter, shift enter, and as you can see we have our graph in a scientific manner. So you can just play around with these commands. And another important thing is to label these plots, right? Because we need to know what is on the x-axis and what is on the y-axis. So now we want to add this label. So how to do that? The way to do it is to use the command called plot label. So how do we do that? Let's see. Let's just put our cursor over here. We put another comma because we are adding an attribute. So plot, as you can see, we already have this plot label, and if you use this plot label, then let's say I'm typing this thing right in the y-axis. This is the function that I'm plotting in the y-axis, its value. So just use this and hit enter, and as you can see it has given us 0.5x sin x. Okay, that's good. So this is how you can make your graph as detailed as possible. You can also make them more convenient for you. So what you are seeing is that I have plotted the sine function and the cosine function together. To do that, what I have done is that I used a command called show. So what does this command actually tells us? Let's see. I clicked on the information. It should pop up a window. Yes, it has. And first you give your graphics and then with some options. As you can see, there are some examples over here. So you can take a look at these examples to know how you can polish up your graph for your own advantages and stuff like that. So for our purpose today, we will just only see how you can plot two graphs together. So first you do is that what you do, you just type show, you put two third brackets, but then you want to plot, right? So in this case, that is already done here, is that I have plotted the sine and the cosine, and note that I have used another attribute called plot style. So this plot style actually gives you the color. For example, if I just, instead of red, I want to say, let's say green. So if you do that, yeah, so this green is your sine function, and notice that I haven't used any plot style over here. I can do that. So just use plot style, if you type on thick, if you typed on dashed, then look what happens. See, this line is now dashed. So instead of that, if you had selected thick, now this line is a bit thicker than the green line, that is the blue line. But plot style actually gives you the color. Let's say green, let's say I want to type it orange. It should start with a capital O. Oh, Mathematica typed it for me. And as you can see, you have orange. So first you type show, the thing that we're discussing, that we want to plot. Let's say I want to plot 3 graphs together so that I can compare them, or whether they intersect or not. That's the thing I want to see. So after giving this third braces, you need to put some curly brackets, because what this will do is that it will gather these plottings and then it will superimpose on them. That is putting one graph over another. So let's type plot. I want to see the expression of 2x plus 3, let's say, and I want to plot it for -6 to +6, let's say. That's my interval. And what I want to do now is that I want to go to plot style. I want to plot it as grid, and then you put a comma. Why you are doing this, I'll explain it in a bit again. So now you want to plot another graph. Let's say I want to type sine. No, we have done sine, right, already? Okay, so let's do tan. Let's see how tan's graphs looks like on this interval. So x equals to, again I'm taking the same interval. You can even take different intervals if you want. And I'll use plot style. Let's say I want it to be dashed. Alright, and using the default color as well. So you are done with the number 2, and then you want to plot. Let's say now I want to plot the exponential -x, comma. So this is from, again, -6 to 6, and I want to plot style. It should be blue. Okay, so let me explain what is going on around here. But okay, just look at the output first. Let's try to look at the output first, just to see whether we have done everything right or not. As you can see, this range is, oh, I think I have written, oh yeah, this range specification -6 plus x is not in the form of x min x max. Okay, so as you can see, guys, I have already made a mistake, and this is the mistake. So please take care when you type these codes. Mathematica will show you errors. If you have any errors in your code, it will pop up. So now it seems fine, and let's run it. There you go. So this red line is our straight line that comes from 2x plus 3. This blue line is coming from e to the power minus x, and these dashed lines are coming from the tan x graph. So what is happening here is that first you are typing the show command, and then you are putting the curly braces. And in curly braces, after typing each plot commands, you have to put a comma. So what these curly braces are, it's a list actually, that first you are plotting this 2x plus 3, then you are plotting 10x, and then you are plotting e to the power minus x. And then what is happening is that you are putting these three graphs on top of each other so that you can compare. So this will be it for today. So far we have only seen plots up, but we'll talk more about plotting in our next lectures. And today we would like to finish by showing just one little final thing, that is the limits. So let's talk about limits. So let's say I have a function let's not type f of x. Let's say you have a function called h. I'm not typing f of x again because in the previous blocks, or that is the previous cells, I have typed f, and Mathematica will get confused because we have to go up and remove it again. So I don't want to do that. So let's type h of x as a function, and let's take it to be a very simple function. Let's say I want to write a fractional function. Let's say x minus 3, x minus 1. And I want to know what is the limit. Okay, I run the code and Mathematica is showing me the output. Oh, wait. I missed a column. See, this type of thing can happen, so please be careful about it. So what I want to see is that what is the value of this function when x approaches 1. That is, whether there is any value of h of x when x is equals to 1. And if you're familiar with limits, you already know that as x approaches 1, this thing should blow up. Let's see what Mathematica tells us. To type to find out limit, first you type limit till limit, you click and enter, you put some third braces, and to know the functionality of this command, you just see below that you type this f of x and you specify what is the argument, and by x star is the specific point you want to evaluate the limit at. As you can see, it is showing us that gives the limit when x goes to x star, right? Okay, so we'll do this in a hurry. H of x, and we'll put a comma, first type x, then do this right arrow thing, put in a space, and Mathematica automatically fixes it for you. And I want to type x goes to 1. As you can see, this is indeterminate. Let's say I want to type x equals to 2. As you can see, this is minus 1, right? Okay. What if x goes to infinity? So to type infinity, first type backslash, then put one of the third braces, and as you can see that Mathematica is already treating the third bracket that I put before and the one with the after is as a single entity. But if you see this kind of thing, just put another third bracket and everything should be fine, and just type inf infinity. Oh, there is a extra, yeah. And as x goes to infinity, this is just 1. And this is something you can do from calculus things, right? You divide the numerator and the denominator by x. So what you have in the upper portion is 1 minus 3 divided by x, and in the lower portion 1 minus 1 divided by x. And as x goes to infinity, your limit becomes 1. So this is how you can evaluate limits of functions, and that will be all for today. And thank you, and I'll see you guys on the next lecture.